We're going to have a look at ammeters and voltmeters. We're going to look at what they are, how to connect them up, and then a few more little bits about circuits that are quite interesting. Just to recap from one of the other videos, current is the rate of flow of charge. You need to know that. It's measured in amps, and we use an ammeter to measure it. Here's an analogy we've used before. So we've got peas travelling around a pipe, and there's a mouse in a treadmill. Now ammeters measure the rate of flow of charge. And using this example, we would have to count the amount of peas that pass a point every second. So we would place the ammeter just here so we can count the peas going past. In the same way, in an electrical circuit, we place the ammeter in series and we can literally count the amount of charge that passes a point every second. Using the electrical diagram, the ammeter must be placed in series. Now try and think of it as the ammeter has to count the electrons that pass, so it has to be placed in the way. It doesn't matter where the ammeter goes as long as it's in series. It could be on the left or it could be on the right. It could be at the top or the bottom. It doesn't matter as long as it's in series. Now voltage is the energy per unit charge. It's measured in volts and we use a voltmeter to measure it. Here's a diagram of a simple electrical circuit. Now the electrons come from the cell at the top, they travel down this wire, through the bulb, and then back up this wire, back to the cell where they can gain more energy and continue to go round and round the circuit. Now the energy of the electrons at this point, just before the bulb, is quite high because it's just come from the cell. Then the energy is transferred to light in the bulb, as light in the bulb, and then the energy of the electrons after is slightly less because the energy has been transferred to light. And then the electrons can carry back up to the cell where they gain more energy through the cell and then lose the energy through the bulb. Now what voltmeters do is they measure the difference in energy from the before and the after. That's why voltmeters must be measured in parallel. You must choose the component you want to measure. You connect one before and one lead after, and then it's the difference that we're interested in. And this is called the potential difference. And that's the difference in energy from one side of the component to the other. And potential difference is sort of a technical name for voltage. Lastly, I just wanted to describe the energy transfers that occur through a circuit. And just like I said before, on a simple diagram like this, the electrons gain energy through a cell, travel down this wire, through the bulb where their energy is transferred to heat and light energy, and then back up this wire, and then they travel through the cell where they gain more energy, and this continues to go round and round. So they gain energy through the cell and lose energy through the bulb. Now this is called work that work is done by the electron on the bulb. And that just means that energy has been transferred. The last thing I wanted to go through was some incorrect versions that many people get wrong. So this one on the left has the ammeter connected in the wrong place. Now this is wrong because the electrons don't travel through the ammeter. They go from the cell through the bulb and back to the cell, and they continue in that loop. Now the ammeter has to count the amount of electrons that passes that point every second. So therefore, if it's not in the loop, then it won't be able to count it and it won't measure anything. Here's the other one that people get wrong commonly. Now the voltmeter, remember, has to measure the difference between before and after of a component, before a component and after. Now here, it won't be able to measure before and after, so it will not measure any value at all. Now remember, these are incorrect values, so these are all both wrong. And as long as you understand that they're wrong, then hopefully you won't make that mistake in the future. Just to recap, the ammeter must be placed in series. The voltmeter must be placed in parallel. Now the voltmeter must be touching both sides of the component you wish to measure. So if there was more than one component, you have to choose which one you want to measure and put the voltmeter either side of that component. And that measures the difference in energy. It measures the energy before and the energy after, and it tells you the difference. And that is what we call potential difference.